In my last video, I explained capacitors and derived the expression for capacitance of a parallel plate capacitor with air in between the plates. When air is in between the plates, capacitance is given by this relation. C0 is epsilon 0A by D. In this video, I am going to explain effect of dielectrics in capacitors. Here there is a capacitor with air in between the plates. At that time, electric field in between the plate is E0 when you connect a battery. Potential difference between the plate is V0. Electric field is E0. Charge is Q0. Now you disconnect the battery and then introduce the dielectric. Another method is there without disconnecting the battery, introduce the dielectric. Now battery is disconnected, then we introduce the dielectric. Now electric field will be reduced. Experimentally, it is observed that electric field will be reduced. Electric field after introducing the dielectric is given by this. E is equal to E0 divided by epsilon R, where epsilon R is relative permittivity. Then here some dielectric like mica or paper is introduced. So for that relative permittivity is greater than 1. That means electric field will be reduced. You are dividing by a number which is greater than 1. So E will be lesser than E0. Electric field is reduced. So potential difference between the plate also will be reduced. Without dielectric, potential difference is V0. After introducing the dielectric, potential difference is V. So V is equal to E into D. For this E, you can substitute this E0 by epsilon R. E0 into D is V0. So this is the potential difference after introducing the dielectric. So that is reduced. V will be lesser than V0. E is lesser than E0. Similarly, V is lesser than V0. Then capacitance is inversely proportional to the potential difference. That means when potential difference decreases, capacitance will increase. But the charge will remain constant when battery is disconnected and then introduce the dielectric. Charge will remain constant. Electric field is reduced, potential difference is reduced. So the new capacitance C is equal to Q0 by V. Initially, before introducing C0 is Q0 by V0. Now new capacitance C is equal to Q0. You can see charge remains constant. Potential difference between the plate is, as per this expression, reduced. So instead of V0 you can write V. Now this is a new capacitance. C is equal to Q0 divided by V. Q0 divided by V. For V we can write V0 by epsilon R. So it can be written like this. This epsilon R will come to the numerator. So epsilon R Q0 by V0. Now C is equal to epsilon R C0 because Q0 by V0. Q0 by V0 is C0. So C is equal to epsilon R C0. For this we can write C0. So epsilon R is greater than 1. That means C will be greater than C0. So capacitance will increase. When we introduce a dielectric, capacitance will increase. C is greater than C0. So C is equal to epsilon R. Capacitance of a parallel plate capacitor with air in between the plate is epsilon 0A by d. For this we can substitute epsilon 0 A by d is equal to epsilon 0 into epsilon r is epsilon A by d. So this is the expression for the capacitance of a parallel plate capacitor with dielectric in between the plates. Energy stored in a capacitor is given by this relation, U is equal to half Q square by C. With air in between the plates, U0 is half, charge is Q0, so it's square, then capacitance is C0. With the dielectric, energy stored is U, so U is equal to half Q0 square. Instead of C0, now you would write C. For C, we can write this epsilon R C0, but half Q0 square by C0. For that, you can write U0. So this is the energy when dielectric is there in between the plates. This is the energy with air in between the plates. So U is equal to U0 divided by epsilon R. Epsilon R is a number greater than 1. So U will be lesser than U0. When we introduce a dielectric, some energy is utilized for pulling the dielectric inside. That's why energy is lesser. U is lesser than U0. Now let us see the second case. Dielectric is introduced without disconnecting the battery from the capacitor. Now charge changes. From Q0 it will become Q. But potential difference between the plates will remain same, V0. With air in between the plates, capacitance is given by this relation. C0 is Q0 divided by V0. After introducing the dielectric, charge is Q. Q is equal to epsilon R Q0. It is experimentally found. Charge is increasing because epsilon R is greater than 1. So Q will be greater than Q0. So capacitance increases in this case also because there is an increase in the amount of charge. In the previous case, there was a decrease in the potential difference. So the capacitance, in both the cases, capacitance increases. In this case, increases because of the increase in the charge. C is equal to Q by V0. For this Q, you can write epsilon R Q0. So C is equal to epsilon R Q0 by V0. Now C is equal to epsilon R Q0 by V0. Q0 by V0 you can write C0. Epsilon R is greater than 1. So C will be greater than C0 because this is greater than 1. So C will be greater than C0. Then capacitance of a parallel plate capacitor with air in between the plate is C0 is equal to epsilon 0 A by D. So for this we can write epsilon 0 A by D. Epsilon 0 into epsilon R is epsilon. So C is equal to epsilon A by D. So this is the capacitance with dielectric in between the plate. C is equal to epsilon A by D. Now energy stored with air in between, energy stored is U0 is half C0 V0 square. In the previous case we used this expression, but now we cannot use that expression. The reason here both are Q0 charge is changing, capacitance are also changing, so we cannot use this expression. If you use this expression, only capacitance is changing, V0 voltage is not, potential difference is not changing. So U0 is half C0 V0 square. After introducing the dielectric, energy is half C V0 square. Instead of C0, we have to write C, new capacitance. So now for the C, we can write this C is equal to epsilon R C0. For the C, we can write epsilon R C0. Now you can see here half C0 V0 square, half C0 V0 square. For this, we can write U0. So U is equal to epsilon R U0. Epsilon R is greater than 1, so energy stored with the dielectric is greater than energy stored without dielectric. U is greater than U0. In this case, capacitance increases because there is an increase in the charge. In the previous case, capacitance increases because of there is a decrease in the potential difference between the plates. In the previous case, there was a decrease in the energy, but here there is an increase in the energy. Now, potential difference same between the plate, potential difference remains same. So electric field also remains same. Energy density is given by this expression, half epsilon E0 square. I hope you have understood the effect of dielectrics in capacitors. Next video, I will be explaining distribution of charges. Thank you for watching.